Well, hello everybody, and welcome again to the OpenShift Commons briefings. This is a series in which we're sort of starting to take a step back and do some introductions to Kubernetes and other things and other projects. And Burr Sutter, who is with the Red Hat Developer Program, whom I'm sure a lot of you already know, has come to tell us 9 steps to awesome with Kubernetes. I'll let Burr introduce himself and take it away. We'll have live Q&A, and the slides will all be available on YouTube, and we'll be making it available through the OpenShift blog. So, Burr, take it away.
Fantastic. So the opening slide here, you can kind of see that I have a GitHub link that will be where the written materials are, and you'll even see me pull from those materials as an example. So that is approximately a 3+ hour workshop that I run with different outlets, and so that's the materials for that 3-hour workshop, and we're going to cover part of that today. And the slide deck itself is at bit.ly 9 steps awesome. That'll get you access to the live Google Doc, and that'll get you literally will land right here in this document. And if I break out the document here, you'll see like already 19 people are connected to my document live, and then you can basically say, you can come over here and say make a copy or do a download to PPTX. Then you have your own version of this as an example. So I tend to open source everything, and we've definitely made no exception of this slide deck also. Okay, so a little bit about me. I'm currently the Global Director of Developer Experience, meaning I travel the world. I talk to people all over the planet. And the thing I love talking about the most, though, is Kubernetes. Kubernetes, Istio, Knative, Tekton. Those are the subjects I tend to focus on, a little Kafka, a little Stremz, things like that. Today we're going to focus on the basics, though. Just the basic kind of getting started experience for the person who's new to the Kubernetes ecosystem, only because I think that's a fun place to start, and everybody kind of needs to know the basics in order to move down the fancier path of Istio or Knative or Kafka, as an example, those more advanced topics. Okay, now one thing that should be noted, I'm a developer, and I'm specifically a Java developer. So I know some of you on this presentation or even watching this recording are like, oh my God, you have to hear from a Java person. I respect that. You might even see some Java code just briefly, and I don't want anyone to be offended by that. Java is still awesome and doing incredibly well throughout the enterprise, and so maybe I'll throw a little JavaScript in there too to make folks happy, a little diversity, if you will. But just keep that in mind. I'm going to come at this from a developer perspective. So remember that. If you have operational concerns and deep dives and all that, I tend to ignore all that. I don't know how to configure the storage in all the best ways to make sure that it's well maintainable and incredibly scalable. As an example, I tend to focus on what a developer needs to know to use Kubernetes successfully. Okay, so we're going to dive right into this. We have a lot of learning resources with my team here at Red Hat. If you're interested in the Kubernetes tutorial, the intro, that's the first 2 links there as a high level, right? And then you're going to get into the Istio stuff, then the serverless stuff with Knative, and the Tekton stuff. Actually, we just moved out into its own tutorial. There'll be a new link here on my deck. And that's another good thing, is if you have access to the live deck, you'll see it as I make changes to it. I'm not going to run any of these advanced demos today. The blue-green canary deployment with Istio, which also includes Tekton pipelines. Side by side, which is a Knative auto-scaling demo. There's a Knative Kafka demo that does high scaling based on Kafka load, things like that. There's also my hybrid cloud demo where we bounce transactions from Amazon to Azure and Google. We're not going to do any of the fancy demos today. We're going to really focus on just the basics. But you have access to these links in case you need them for your future reference. And there's plenty of videos at YouTube and whatnot that show me doing these various presentations covering those different demonstrations. I also have a video form of this thing, right? So we're kind of doing a live session today, but I have a video form that you can kind of watch, like 6-7 hours of all this stuff as well if you want to, and that's over on the O'Reilly platform. And then I tend to run these classes with O'Reilly every couple months. Sometimes I run them every month. Sometimes I skip a month. But you can kind of see the 9 steps to awesome, which is our basics class, is what we'll be covering in a short form today. Okay? Now, if you were doing this hands-on, we won't have time today. You would basically have to hit that first link or the second link and kind of figure out how to get started. The instructions primarily were originally based on minishift. I've since been migrating them to minikube over time, as minishift has kind of fallen off the Kubernetes curve, if you will. It's on an older version of Kubernetes, and I'm trying to keep up closer to, let's say, 115, 116 level. Now, today, I think I'll just use 114, but it doesn't really matter so much from the experience we need as a developer. There's a couple other things that you might be impacted with based on your hypervisor, right? So the virtualization technology you have on your laptop can greatly impact your ability to use a minikube or a minishift. And I know that many people fail with using minikube or minishift on their Mac, on their Windows machine, on their Linux machine, based on the fact that their hypervisor simply just isn't configured correctly. So there's some tips there for that just to help you out. All right. Now, this is one slide I tend to use in a lot of my presentations. If you've watched this before for me, I recognize you're probably bored of it, but I love it. It's fun, but it helps give us context. And that is, if you're working your way to being awesome when any new technology, don't look at the technology as a silver bullet. Don't look at the technology as, oh, it's going to cure all kind of thing, feed the hungry, clothe the naked. Really, a technology is just a tool, and one of the tools you might use to be more awesome. So your journey to awesomeness, though, really starts with DevOps and the principles of DevOps and the cultural change and the rethinking of the way you organize work in your organization will really have a greater impact on your journey to awesomeness more than anything else. And that's not really our focus today. We're not going to focus on DevOps per se. We're going to focus on a bit of tools, which in this case is called Kubernetes. All right. Now, self-service and on-demand elastic infrastructure, that's a key one. So if you actually are filing a ticket, waiting 2 weeks to get a resource, then you have a problem in your organization, right? If you're waiting 2 weeks to get a virtual machine configured correctly, and then, of course, it's not configured correctly when you receive it, well, that's the typical life cycle we see in many, many enterprises, right? File a ticket, wait a week, get the resource is not right, file another ticket, wait another week, and then hopefully it comes out the other end okay. That is no longer the world we wish to live in, and we want to live in a self-service, on-demand, elastic infrastructure world where we have an API, we have a quota, and we basically just launch whatever the hell we want to launch when we want to launch it, as an example. All right, automation. No more, feeding CDs into CD trays or DVDs into DVD trays. No more SSH into a node and yum install this and yum install that, apt-get, install, etc. Basically, you need to have some form of playbook at this point, right? Or even at least a fancy bash shell script, I hope, as an example. CI/CD deployment pipeline, another aspect of being on your journey to awesomeness, another aspect of being more mature. Can you automate those pipelines as an example, or is it just on the back of a napkin? Many people still have their pipelines on a whiteboard, not in code, and so that's still a problem for us as an industry. Deployment techniques like blue-green deployment, canary deployment, we won't really get a chance to see much of that today because, again, it's more advanced, but it's definitely part of the Istio stuff that we teach and things of that nature, and it's definitely a powerful aspect, a powerful feature that you can take advantage of to build out your next-generation infrastructure, your next-generation applications. And then you, too, can be like the GitHub unicorn. I love the pink, snarly unicorn with the rainbow mane, right? That's the GitHub unicorn, by the way. I'll just tell you where I stole it from. It used to be like their 503 symbol. It may still be at this point. But I know everybody wants to teleport themselves directly to microservices. That's what everyone says they're doing. We're doing microservices. But I'm telling you, all these other things really matter. And in our world, what we're going to talk about today is where Kubernetes, OpenShift being Red Hat's distribution of Kubernetes, and there's many flavors of OpenShift out there in the world, right? There's OpenShift, and we'll talk about some of those. There's OpenShift, like the main one you get for production purposes. There's one you can run on your laptop for development purposes. There's OKD, the upstream technology that you can basically download and use wherever you like, right? Lots of versions of that out there and available to you. And this other symbol you have on my chart here is Istio, which is a technology that helps you with those fancy blue-green deployments and canary deployments as an example. Okay, so let's kind of dive into this. All right, we're going to live in this new school world, not the old school world. All right, new school says we're going to have a whole big bunch of services, microservices, let's call them, and they're going to be distributed around a network. There are going to be multiple entry points. We have to think about our APIs, our API gateway, or API management. There's going to be numerous databases involved, right? There's going to be many, many teams building out their application and having their own individualized deployment pipeline to deploy into production on their day, on their night, on their weekend, at 2 o'clock on Friday, at 9 o'clock on Monday, right? All that is the new school world. If you live in the old school world, right, one deployment every 6 months, big old team, deploy every 6 months, and we deploy every 6 months like clockwork, yeah, you can do that with your old school VMs. You don't need all this fancy Kubernetes stuff for that, all right? Can you use it in Kubernetes? Totally. But, Kubernetes is really going to give you a big win when you actually start living in this new fast cycle time world where you're building out, deploying microservices and rocking them out there. Okay? The 9 steps class we try to go through in about 3 or 4 hours normally does cover, a lot of things like installation and getting started, building images, running containers, how to get the logs, how to do execs, how to set up configuration like config maps and secrets and things like that, service discovery, load balancing, live and readiness probes. And what I'll do is I'll just kind of do what I call my quick start that covers the highest levels, to basically so you can see what it means to build an application and get your application running on a Kubernetes cluster, whether that be any Kubernetes cluster or an OpenShift cluster. It doesn't really matter. We'll show you how to kind of get started from that perspective, and then that at least get you able to dive deeper into this Kubernetes world and into the OpenShift world that you might be trying out as an example. Okay, we'll do a little rolling update. We'll do a little live and ready because those are so critical in this world to make sure you understand how to get those set up. I think we can get all that done in the next hour or so. Okay, but the introduction. Here's one thing I love telling people about because I used to teach Docker many, many years ago, right? So I used to teach people about the Linux container, Docker specifically. So Docker, right, was what we used way back in the day. And then this is the magic that Docker solved that really blew everyone's mind when it came to the market. So again, I'm a Java person, right? So in a Java person, they had this issue. They basically had to figure out where their application was going to land on specific server hardware, with a specific operating system on that server hardware. In the case of Java, as Java people, we're used to living in a world of Solaris and AIX and Linux and Windows and you name it, right? Java people kind of surf all the operating systems. And then, of course, their JVM has to be a certain version, a certain configuration. That's critical. Their application server really mattered to us, right? We had WebLogic or WebSphere or Tomcat or JBoss. That really mattered to us. And, of course, we had a custom configuration that sat on top of that. And on that stack, on that basis, was our EAR or WAR or JAR, our application code that sat on top of that stack. But here was the problem. This stack was almost impossible to maintain. It basically was broken everywhere we went. We actually tried to document the stack in a nice email. We used to send nice emails to people and say, hey, here's what my code needs. It needs this version of that and this version of that and this configuration and that configuration. And for people who got super fancy, they took the email and they made a wiki page out of it. Right? You guys remember wiki pages when we used to do wiki pages? Well, even that was broken because the documentation was always out of sync with the reality of the code base, right? So the beautiful thing that we learned in the world of Docker is this thing called the Dockerfile. The Dockerfile is absolutely magical, right? The Dockerfile is still what we love to this point, to this day, and still critical to how we have to think about the world. The Dockerfile is something we check into source code repository, and we basically put in there explicitly what our application needs. It needs this operating system and this application server infrastructure and this JVM or this Python runtime or this Node.js runtime or whatever it needs, right? It basically covers all those things for us, including configuration and copying in the files and laying in exactly the application as we need it. So that was really the magic that turned the world around because it basically allowed us to codify these rules as opposed to emailing these things back and forth. Huge win for the world. Now here was the challenge, right? Now we figured out we solved that one problem, and we had this cool thing called the Linux container that came out the other end. We then had to figure out how to manage them at scale, how to deal with port conflicts. Like if you're running on your local laptop, like I am right now, you might have a concern specifically for how to deal with, port 8080. If you're living in the Java world, 8080 comes up a lot, right? That's where all the Java guys love to run, 8080. And now you have all these microservices, and you got like 14 of them running, and you got 14 things running on 8080. It doesn't really work, as an example. So this is really where something like a Kubernetes has really come in to help us, okay? So Kubernetes was born back in 2014 as an open source project. It was actually something that we started contributing to at Red Hat right from the very get-go. And of course, we launched our own supported Kubernetes known as OpenShift as an on-premise solution for the market at large back in 2015. Okay, so we've been doing this for quite some time. And I've been playing with this thing for quite some time and really enjoying it. And so here's kind of just a little quick history on Kubernetes, though, right? You can think of the Greek term helmsman or governor. That's kind of where people say this refers to. Basically, the concept is Kubernetes is the admiral, if you will, of your fleet of ships. That's how I like to think of it. So you have all your fleet of ships out there that need to be coordinated. They need to be sailing in the right direction, not running into each other. Well, that's kind of how I like to look at it from a Kubernetes perspective. So it's your container orchestrator. It'll support multiple cloud environments and bare metal environments. So you don't need a virtualization system in many cases, like OpenShift will sit directly on bare metal, as an example. It's inspired by Kubernetes experience with containers. If I was a Google person back in the day, I would say, and we launch 2 billion containers a week. That's the thing they used to love to say. So Google's done a ton with containers over the last decade or so, or actually at this point, 15 years. This thing is all written in Go and in open source, so if you want to go modify it, you'll have to kind of learn the Go programming language, and I can tell you that is not me. I'm a user of Kubernetes, not an extender of Kubernetes, okay? I'm really focused on my applications and trying to make those applications run successfully. That's what I care about as a developer. So some key things out of the gate: self-healing, horizontal scaling, auto-scaling, horizontal manual scaling, things like that, automatic restarting. That's actually a huge win, by the way, the automatic restarting. For those people who've lived in the Java ecosystem for some time, you have whole operations teams whose job is to restart JVMs. So now it gets an automatic restart. Big win for a lot of people in the Java ecosystem as an example. Load balancing, rolling updates, rolling upgrades. We're actually going to see some of these things in action, and I'd rather get to the live hacking mode if we can. Okay, huge ecosystem in the Kubernetes world. So if you can probably think of the use case, there's probably someone trying to solve that problem. And as a matter of fact, there's probably like 8 people trying to solve the same problem. Look at service meshes, right? There's like 15 of them at this point, I think. So depending on the use case, you're going to find a lot of people adding to that ecosystem and giving you all these different options. That does make it more complex for those of us as users, though. People who wish to just use Kubernetes, we have to think through, well, what storage do we want? What logging? What metrics? What this? What that? What that? So it does take a little bit of effort to kind of curate this ecosystem and figure out what you need from it. Okay? Now the concept of the pod. Now we're really getting into it now. We're going to talk about pods. We're going to talk about the core components. We're going to dive right in and do some live hacking with you guys here in this session today. But the pod is something you got to get your head around. The pod is where your code runs. The pod is your server. The pod is your application host, if you will. It is where your JVM runs. It is where your Python runs, your Node.js runs, your Go code, your C++, your C#. Doesn't matter what it is. Pretty much if it runs on Linux, it's going to run in this thing called a pod. Okay? Now, the pod seems like an odd word because normally we think of these things as containers. But here's the trick. A pod can have more than one container. It can have more than one container in there. It can have 2 or 3. And if I actually were showing you Tecton right now, you'd see like 11 containers running in a single pod. I know, mind-blowing, right? So a pod is a group, if you will, a family. And if you think about it from this perspective, a pod is a family of whales. And you can see over on the right-hand side here, I have some whales. You might recognize where those whales come from. So more than one container running in a pod, okay? So the pod basically can have more than one container and has a shared IP address. So keep that in mind. You can have port conflict within a pod, all right? So if you have 3 containers all trying to put themselves on port 8080, that could be a problem, but you would really never do that. But I have seen people run into that problem where they kept throwing too many things into a single pod. By default, just try to put one thing in a pod. If 2 things show up, know that that's not necessarily normal. But you will see it when you add things like a sidecar for Istio or a sidecar for Knative, or maybe you do the fancy Tecton thing. You might see more than one container in a pod. Today, we're going to be 1-to-1, one container, one pod. All right? Shared lifecycle, shared storage, shared resources. Pretty much the pod is your computer. Okay? Your JVM, your code, your Node.js, whatever it is, thinks the pod is the computer. That's the easiest way to think of it. Now, we have this other thing called a replica set and a deployment. We're going to see those in action as well. And the replica set and deployment are the declarative state where you say, I want X to happen. And by X, I want to run this Linux container image. I want to run it 3 times. I want to run it with this set of resources like memory and CPU with this liveness check and readiness check. So this is pretty much a YAML document that you can keep in your source code repository. And you're going to throw it over at Kubernetes, and Kubernetes takes that YAML document and makes the world happen. All right, so you give it the YAML artifact, the resource, and it makes the magic happen for you. All right, there's also the concept of a service. This is actually a core piece of the magic of Kubernetes that I believe fundamentally was a game changer for us as a world because they separated the IP addresses in those pods from the world via this thing called a service. The service is the DNS entry. The service is the IP address that the world talks to. When I say world, I mean the other guys in your cluster, okay? And they talk to that service, like the customer service, the preference service, the recommendation service, the inventory service. They talk to that service, and the service then talks to the pods, okay? It's not a direct connection to each pod. You can kind of ignore those pod IP addresses and think about the service as your primary entry point to all those pods. And you'll see why that is when we get into the live hacking session, all right? You also have the concept of PVs and PVCs. So if you do need non-ephemeral storage that exists beyond the pod lifecycle, like a database as an example, or a Kafka broker, then you want to set up the PVs and PVCs, persistent volume claims. And a lot of the magic happens based on labels. Okay? So what I want to do now is I want to kind of get in here and start hacking on some stuff, though, and showing you some things, because we rather show you some fun stuff than have you guys sit there and listen to slides, unfortunately, for too long. Now, one thing is I'm going to go in and I'm going to use my own documentation because it's easier for me to remember all these crazy commands. And in some cases, it's actually easier to copy and paste them. So let's do that. Okay. I've already set up my environment variables. So these are the key ones you would use if you're using minikube. And I'm going to use minikube today because it is a nice baseline to get started with, right? So minikube is the easiest way to get started in a Kubernetes ecosystem. The beautiful thing is it's all under your control on your laptop. And therefore, if you want to burn it down, and I literally just burned mine down, I just destroyed it, I can recreate it and bring it back to life. So that's a beautiful thing by itself. There is another technology out there called code-ready containers, which is an OpenShift for your laptop. And it is running over here. As an example, let's see, I do have it running. Oh, I don't have that in my path, so it's right here. So it is running, but I haven't really spent a lot of time with it and really haven't had a chance to really exercise it well. How about that as an example? So I'm going to just let that be, and we're going to focus on our minikube. You can also do an OKD where you install it, OKD4, install it on one of the public cloud providers. And normally I do actually install an OpenShift on an Amazon, on a Google, on an Azure when I want to basically set up something more interesting. But today I'm going to just pretty much use my minikube environment. Okay? So let me just export my variables into my terminal here. You can see I basically have minikube, home, path, config, kube config, very important. I do this so I can keep my worlds separate, apart from each other, all right? And then the kube editor. You'll see the kube editor live later on, but it's a very powerful setting that you might want to take advantage of. And then you basically can just run your minikube commands to get it started. So I'm just going to copy and paste those in. And so you can kind of see what those are in the documentation. Let's go here. And I will bring these up here, okay? You basically would just set up minikube to basically how much memory you want, how many CPUs you want. In my case, I tend to always use the VM driver VirtualBox. You can pick and choose which one you want here, but I use VirtualBox because it's available to me on Windows and Mac and Linux, and so it's a little more universal from that perspective. Today, I have it kind of hard-coded to 114, but this is important to note. You will want to be specific about your Kubernetes version, knowing which one you might have in production, okay? Most people are still kind of 114 and older. The 115, 116 are currently out. Every now and then you will see me use a later version. 116, though, does have a kind of a feature, if you will. It has deprecated some of the APIs, and therefore some of your older YAMLs will fail on 116. So just be aware of that. So you might actually get burned on that one. I've actually got burned on that one myself. And then I couldn't figure out why, and then I realized I was still using the older alpha or beta versions of things, like a deployment is a good example. All right? And then, of course, there's this concept of a profile here. Now, the profile allows you to have different minikubes up at any given moment. Like I might have 3 minikubes, 4 minikubes up at any given moment. The profile helps me keep those worlds separate, along with having a good kube config and knowing where the kube config is. Okay? Now, when this thing is loading, you'll see that it basically has to go through the process of bootstrapping itself, and then it'll do a download of kubeadmin and kube control and some other things. You'll see those things downloading. Since I had previously started on this machine, it's not going through that download process. It's just simply waiting for the cluster to get built inside that virtual machine and get started, okay? And you can even say it's complaining to me that 114 is a little bit old, and I have a 116 client. And that's okay. So now, once it's up, you say cluster info, okay? kubectl kube control cluster info is probably the first command you want to run. So this is known as kube control or kubectl. It's one of the key tools that you'll have in a Kubernetes ecosystem to know what's going on. And cluster info lets you know which cluster you're connected to. So that's a big one. Another one is kube control get namespaces, all right? And we'll talk more about namespaces in a second. But I need to know what my namespaces are. These are folders, if you will, that you would load things into. It's an organizational structure. Now, namespaces actually have some additional capabilities, like settings of quotas and limit ranges and RBAC, right, role-based access, things like that. So you need to be aware of those things. But by default, just think of it as a way to group stuff in your early getting started experience, right? So just keep the mind that those things are out there. And there's other things out here like kubectl get nodes, all right? Another thing. We're going to talk about nodes in a moment. But nodes basically tell me what worker nodes and master nodes I have. And a minikube, or CRC, code-ready containers, or a mini shift, the old mini shift, has a single node. It's a master and a worker in one. Okay? So that is kind of the bare bones of just getting a cluster up. Just running those minikube commands and seeing it work for the very first time could be a massive win for you, getting it running on your laptop. But do keep in mind, it doesn't run on every laptop. It just it can have struggle with your hypervisor, your virtualization settings, your configuration, and it just may not work. I warn people of that because it does have a kind of a known failure rate. Okay, let's jump back into slide mode and kind of explain what this master and all this kind of stuff is, all right? Because I think it's important to kind of comprehend what we're looking at here. So I am the developer using this tool called kubectl. It has different names. Kubecontrol is the official name, according to most people. kubectl for maybe older people like myself, who just that's what I started calling it before someone decided it was really called kubecontrol. Some people call it kubectl, right? You hear the cuddles command. So it's all the same thing. Just at the end of the day, you're going to use this command line tool as a developer or an operations person. You're going to interact with this API in what's called a master node. Typically, you have 3 master nodes in a production environment. So the reason you have these 3 is because of etcd needs 3 for high availability. So etcd is the database where all those little YAMLs you've been messing with are going to be stored. Okay? So you basically create this document, this artifact, this resource, a YAML file, and you're going to chunk it over the wall through the API into the master node. It's going to write that thing to etcd, and that's where it keeps it. Now, once it has your desires, again, defined typically in a YAML form, sometimes JSON, but normally YAML form, it's going to then light up the schedulers and controllers needed to make it real in the world, okay? So the schedulers and controllers are going to make it real, and it's going to make it real by talking to all these worker nodes. So on the right-hand side here, you have the concept of the worker node, and the worker node is just another computer, another virtual machine, so either bare metal server or a virtual machine, that basically will run those pods, right? It's going to run the pods for you, and it's going to use this thing called a kubelet. So basically, the kubelet is the agent that lives on those worker nodes that talks to the master talks to the kubelet. That's how those two things connect, and it's going to basically run these things for you, okay? I like to think of it in its most simplest form of Docker run, because if you were using plain old school Docker, you do your Docker build, you do your Docker run. And if you had a multiple machine, you have many machines, you do Docker run, Docker run, Docker run, Docker run, right? You issue that command 4 times if that's what you needed. In this case, you don't have to worry about that. It's taking care of that for you. It's doing the Docker run for you. Now, the modern Kubernetes distributions that are out there, they don't use Docker underneath the covers anymore, but you can, it doesn't matter to you as a developer or user. It just basically runs your pod. How about that? Runs your container. Now, again, you're going to basically give it a declaration. I want to run my Tomcat from this specific image that was created. I want to run it 4 times. You're going to ship that over to the master. It's basically going to receive that data and then figure out which worker nodes can actually handle it, right? So it's going to drop those 4 Tomcats out there across my worker nodes, and that's pretty awesome. And it'll just make that happen for you, assuming there is space available. You will see a certain word called pending. I don't think I can simulate it today. It takes a little effort to simulate it. But if you run your cluster out of resources, you'll see pending, and you'll have to go digging into that, and then you'll have to figure out exactly why it's pending, okay? It's a tricky thing to simulate. Often it happens to me mid-presentation, so it might happen today. But otherwise, I don't know if I can simulate it and make it reoccurring. Another key feature, though, of a Kubernetes cluster, right, it's always monitoring your environment. If you said you wanted 4 Tomcats and one of your Tomcats dies, it'll ensure that that Tomcat respawns someplace else. I like to think of it as a respawning like you have in a gaming environment. Basically, your character was killed, but it respawns over here in another part of the world, and therefore gets back to the fight, if you think of it from that perspective. So that concept is super critical and a huge feature. Basically, if your pod dies, it finds a new home, and it shows back up again. And depending on your Kubernetes cluster that you have and which Kubernetes vendor you're dealing with, if the node dies, right, if the whole node dies, those pods get rescheduled elsewhere, and they show up someplace else. And even, again, depending on your distribution of this, right, your version of Kubernetes, you will get a whole node back too, right? So it basically self-heals at the node level in addition at the pod level. But I have seen the different versions of Kubernetes from different vendors, have different flavors of that capability as an example. So let's kind of go back into this now, all right? I want to kind of show you some things because we're going to have a little fun with our little Kubernetes here. So we did the get namespaces, all right? Get namespaces one more time. And so I got to type correctly today. I basically have those out-of-the-box namespaces. That is kind of out-of-the-box for minikube. Now, if I were doing this on a OpenShift, okay, let's try it over here on OpenShift. Get namespaces. You can kind of see that there's a bunch of stuff in OpenShift. So OpenShift kind of comes with a lot of things pre-configured out of the box, whether that be your SDN, a console, how to manage networking, all these things called operators, which we won't have time for today. But there's all kinds of magic built into an OpenShift version of this, while a basic Kubernetes would just have these basic ones, like minikube has default, right? And kube system, things like that. If you do kube control get pods, though, all namespaces, and that's a key command you want to remember, because what is running in your cluster? Well, now I know that I have a bunch of things running, and there's that etcd thing we talked about, there's the API thing, right? So this is where things are running. It's running within the system, mostly here in kube system. And it's good to know that those things are out there. Now, I'll tell you, as a new person, don't go hacking on those things. Leave them be. They're fine. Don't mess with them. You want to basically create your own namespace and run your own stuff. Okay? Now, by default, this thing called default is the place you're living and when it comes to regular old Kubernetes. So default is the world you're living in. And so as you create resources yourself, you're going to be living in that default namespace. Keep that in mind. And what I'm going to do is run this command right here and get started. So what we're going to do is run this thing called kube control create deployment. I'm going to give it a name, my app, and it's going to pull from this image, okay, from that image right there. So that's kind of the fastest way to get going, and so that's why I document that way. So you're going to say create deployment, and now you need to kind of poke around in your environment. So if I come over and say watch kube control get pods, you'll see there's a pod coming to life, and it's going through its container creating phase. Basically, it's pulling the image down from the internet, from Quay.io, Burr Sutter, my boot v1. It's downloading that image and pulling it into my environment. Now, how do I know it's pulling the image? You have another command, kube control get events, and I never remember sort by and the syntax here, so I'm going to have to memorize that at some point, because you do want to see it sorted, because by default it doesn't sort. But you can kind of see it says pulling and pulled, created, started. Right? See those four things right there? That is the magic happening right now. So basically, it essentially went out and found the image on the internet, pulled it into my cluster. All right. Once it gets it pulled, then it goes and schedules that image against a worker node. There's only one worker node in this case. Gets it created and gets it started. And then the pod, if you were looking up here, went from container creating to running. All right. One of one running. One container in this pod is ready. Right. That's good. Right. If these numbers mismatch, you probably have a problem. Okay, so if it's 1 of 1, you're in good shape. If it's 0 of 1, you're not in good shape. If it's 1 of 2, you're not in good shape. All right, so try to basically get 1 of 1 here and running, and then you might be okay. I'm not going to say you are okay. You might be okay, because sometimes you can get your pod running and things still aren't quite right. Okay, so what's your next step? Well, I have a pod, and that pod came about because I created a deployment. So if we go over here and say get deployments, as an example, you can see there's a deployment called my app, and I can say kubectl get rs replica set. So here's one piece of the magic already. A deployment creates a replica set. A replica set creates a pod. All right. So those three things happen in concert. If I create a deployment, I get a replica set. A replica set creates the pod, and the pod is the computer in which my code runs. So I want that pod out the other end. Okay. Now there's another command you should be familiar with, other than get. We've been using get a lot here. But there's one called describe, all right? So describe deployment, my app, as an example. And that basically pulls out for you what that document was that was created, right? When I said basically create that deployment, basically this is what was actually created for me. A lot of assumptions were made, meaning the strategy type of rolling update, but this rolling update strategy was an assumption that was made for me. It basically used the image that I gave it as an example, Quay.io, Burr Sutter, my boot as an example. And so it was enough information, right, to get this deployment to run. So one thing I might like to do is say kubectl edit deployment, my boot. Okay, my app. I call this thing my app. So here, edit the deployment. And what that's going to do is throw me into Visual Studio Code. And I can edit this thing in real time here, right? So I can basically say, well, I want to change the replicas. Where'd it go? And now my brain stopped working, so where'd it go? All right, now there we go. I want to change the replicas to, let's say, 3. So save, close, and go back over here. And then, so I basically made a change of replicas to 3. You can see it spins up 2 other pods. Okay, 2 more pods based on replicas equal 3. And again, that edit trick was based on echo cube editor, right there. I sent that to code space W, and that allows me to use Visual Studio Code to do my editing as opposed to VI, right? Essentially, much like Git and other tools, you would just have a VI-like experience otherwise, which is fine, for, if you remember, escape, WQ, things like that. Of course, that's the number one question on Stack Overflow is how do I escape, VI as an example. All right, so I can change my replica count, and then I can come back over here and let me edit it again just to go back to 1, just to kind of keep it simple. All right, let's bring up the Visual Studio Code one more time. Let's see here, make it 1, save, close. Oh, save. All right, and then let's see here. There we go, and 2 of them are getting torn down now. So that declarative nature of Kubernetes is kind of built right into the architecture, right? You basically just say what you want, and it tries to make it happen for you. It's kind of the idea there. So there's my 1 running pod. And again, just to kind of recap, we have our deployment, and we have our replica set. Okay, and the replica set is the controller that's governing how many of those things do you want, right? So I want 1 or 2 or 3 replicas. That's what the replica set's job is. The deployment has a bigger job than that, so we'll get to more of those features in a second. But now I have my 1 running pod. Okay, now how do I know if this thing is really doing what I want it to do, though? So let me come over here and basically say kubectl exec it and name of the pod, then bash. I'm going to jump into the pod. I'm going to shell into that pod, basically. And so I'm going to come in here now, and I can do things like ps-ef, and I can go, it looks like it's a Java application running out here. And I can use top. I can use, I can explore things within that little Linux container if I wish to. But I can also just simply say curl localhost 8080 and see what I get. Aha, so the application is in fact running. It says aloha from Spring Boot, and it also tells me what pod it's running on. That is the host name from a Java standpoint, or Python, or Go, or Node.js. If you say, what's your host name, you get the pod identifier, which I think that's pretty cool, because that's the computer your little Java application thinks it's running on. So I have that now. So I have my app. It looks like it's running. But the next thing is I need to expose the app to the greater world, right? So it's great that my app is up and running, but I need to go through different layers of exposing it to the world. You might remember that I had this thing called a service that had to be created. And if I say kubectl get services, I don't have any real service in this case. Now this one is, again, a default one that comes with minikube. You can kind of ignore that one. What you want is to expose that, the application as a service, and there's actually a command for that. I'm just going to copy and paste it from my documentation, and that is kubectl expose deployment my app, the port I want exposed, and type load balancer as an example. Okay, I'm going to run that command. That does get me a service, and then you can kind of see it right there. Okay, so there's the my app, the load balancer, and you can see right here there it has this little funny port right here, 30117. That is the node port. All right, so if you're dealing with a minikube, node port is your friend. In other words, if you're dealing with a local cluster like I am here, node port is the easiest way to get into that thing and talk to it. Okay, so from a minikube or minishift, if you're using the older minishift, the technique is fairly straightforward. You need to basically say minikube IP. And notice I got an error here, and I have an error. So the reason I got that error is because I didn't actually say what profile. So if you do use profiles, you do have to be a little cautious of this. It's 11 steps IP, and then I get the IP address, and I can basically know what the IP address is of that virtual machine. Or in my case, running a virtual box, you can kind of tell that by the 192.168.99. Okay, but watch this trick. I can also make this profile sticky, meaning I'll run this command, and now I can just use a minikube IP as an example. All right, so now I can get the IP address. I can say curl. Let me go back and get my node port again. And I can say curl, right, 192.168.99, 121. All right, and then 30117. There we go. All right, so now I'm talking to that from my host machine, talking to the, from my host machine into that virtual machine, into that pod, as an example. If I come back over here to my browser, if I want to use my browser also, I can basically interact with it from here too. Okay, so that's awesome. I now know that my app seems to be more or less running. And again, I know which pod it's sitting on. Notice the little counter right here. I tend to do this in a lot of my presentations because I want to know that the JVM has not been recycled, right? The runtime is still up and it holds a state, in this case, a simple counter. So it's a little bit stateful, just so an all-in memory state in this case, but it allows me to know that things are okay and nothing weird has happened. So that's awesome. So I have my service and I can talk to it. So I can even do something like while true. Okay, and then we'll do this curl. Yeah, let's get that. Okay, yep, that looks good. We'll sleep for a little bit so we don't just kind of go too crazy here. And then we'll put a done in. How about that? All right, so there we go. So now we're basically looping along, hitting that pod, interacting with it. And if I come back now and do something clever with it, kubectl edit deployment, my app as an example, I can come over here now and basically hack on it some more. Let's have a little more fun. I'm going to go back to 2 replicas. So 2 replicas, save and close. And yep, here it comes. So you notice right now that there's a second replica coming online, and also notice there's an error message. Do you see that error? So it's cool that it's scaled out, right? I basically said I want 2, it gave me 2, and now I'm kind of highly available, if you will. And it load balances automatically. So the service load balances automatically against all the pods that meet its service selector, okay? But I also got this error message. And then we're going to get back to this in the next few minutes because I want you to be aware that this error occurs and how to address it. But what do I mean by the service, okay? The service, get services. If we come over here and say kubectl, describe service, my app, right here, notice right here it has endpoints and has 2 IP addresses there. Those are the pod IP addresses. And then right here where it says service selector or selector app equal my app. So if I actually come back to my watch up here and get pods, I'm going to say show labels. Let's go show labels. And notice it has my app there. And that label and this selector are what makes these IP addresses show up here for this service. So that's how they end up in the load balancer. If you want to play with this, and there's a whole document I have in my longer course where I basically have you hack into that, and we basically have a Python thing and a Go thing, a Node.js thing. Pretty much you can throw anything in there, and by manipulating the labels, right, you're constantly changing the load balancer and the service, as an example. Okay, but that's kind of the basics of that. Unfortunately, I don't have a lot of time to spend on that today, but it does give you a feel for how this works. Now, let me show you one more thing, though, as it relates to that error message. Let me go back to my loop over here. And watch, let me go back and just go back to replicas 1 just to make it super simple. Keep it a little bit more sane here. 1 replica. All right, I'm going to change that again. And then let that scale down. Okay, there we go. So you notice on the scale down there was no problem. All right, so that's a telling moment. It's like, wait, on the scale up we had a problem, or scale out we had a problem, but on the back when we backed it off there was no error. Okay, so that's important. Remember that one, because that's part of the secret here. Now I have one terminating. We can ignore that for now. It'll get cleaned up soon, but I have the one running. What I want to do next, though, is do a live update of it, okay? So the live update is where the real magic begins. And so what I'm going to do here, there's another command I'm going to use, and it's called kubectl, kube control, set image, deployment, my app, okay? And I believe that container is my boot. We'll find out if I get this wrong. Play IO, and then we're going to basically say Burr Sutter, and we're going to then say my boot version 2. Let's try that. If I got that right, we'll find out if we don't. If I don't have it right, we'll maybe find out the hard way. See the container creating there? Okay, so again, it's doing its pull. If you would go look at kube control get events, you would see the pull is happening, and eventually you get a pulled, and eventually you get a created and started, and then we get a bunch of error messages. All right, but no, now it's working. Wait a second. So what happened here? We went from this aloha one to this bonjour one. Okay, I'm from the South, by the way, so I say bonjour horribly, I know that. But we go to the bonjour one, and now we're okay again, but we got a bunch of errors. So what happened there? So the magic trick here is the liveness probe and readiness probe. There aren't any at this moment in time, okay? There are not any at this point in time, and you want to get to the point with Kubernetes where you understand what those are. You can use them appropriately, because if you don't have them, life is not fun for you, okay? You get all these error messages, your users are experiencing downtime, you don't know why, and it can really burn you. Right? So if you I'm doing a describe on my deployment here, and you kind of see there is no liveness probe or readiness probe set in here. I don't see them listed, and that's because they're not in there. Okay, they're just simply not in there. And what's funny about this though, this is a subtle kind of error. All I did was roll from one version of Spring Boot to another version. Let me actually roll it back. I'm going to go back to version 1. Okay, I'm going to go from Bonjour to Aloha. Now in this case, the image is already downloaded, so that time spent for downloading the image is no longer part of the system. But the bootstrapping of the pod, getting it up, basically gives us this error because it does not yet know that the JVM is up. Okay, so that's the funny part here. Spring Boot boots slowly enough with the JVM coming online, with the Spring Boot framework coming online, and everything coming online. Those seconds that it's waiting to come up are unbeknownst to Kubernetes. Kubernetes is like, the container came up. We saw Linux come up. You must be ready. That's its default thinking. Okay, so it is wrong in this case because our little Spring Boot was not up. And so let me flip it back over to Bonjour. And again, this rolling update, you're going to see it happen here. It's going to flip the user over, but it's sending the user over too soon because the JVM is not quite up and the Spring Boot is not quite up. To kind of make this maybe a little bit more subtle, though, I'm going to change the image out one more time. I'm going to change I'm going to change over to Quarkus because it's also a Java-based application solution. Syntactically, your code looks the same, but Quarkus compiles to a native executable as one of its core features. It has both a JVM mode and a native mode. And in this case, it's doing its pull. All right, it's doing its pull, and you notice it flipped right over, and there was no error message because Quarkus boots so fast that even the curl did not get in there and see the error message. So no downtime from a Quarkus standpoint because it just boots that fast. In any case, you'll want to still fix this concern because you don't really want your users to experience an outage just because you were just doing the rolling update as an example. In this case, I'm flipping back to Spring Boot. Okay, let's do this now. I want to come over here and clean this up a little bit. We have a few minutes left, and I want to show you. We've kind of hit the high points so far, but we want to make sure we cover another key piece of ground, and that is those two probes, the liveness probe and readiness probe I talked about. Let's see here. I got the. Let's clean things up. I'm gonna kubectl delete the service my app. Okay, we're gonna remove that. We're gonna remove the deployment my app as well. I'm just getting rid of that stuff to free up space. Okay, if there are no pods, there's no memory being used. So I'm going to free up that memory, free up those CPUs, just get rid of that stuff. If I say get all here, you kind of see there is that pod that is terminating, and there's that little magical service that's part of the default namespace in minikube. Again, you ignore that one. So let's kind of go do this again one more time to kind of show you a kind of different perspective of it. We're going to go through the same set of steps, but maybe a different order, and I think that'll give you a different perspective. So kube control, create namespace. Let's call this namespace Burr. We're just going to make that one up on the fly. And normally in Kubernetes, you always use the namespace everywhere you go. So when you say kubectl, create or apply or whatever, you normally use a -n and Burr. And I don't like doing that because I'm lazy. So I have another little tool called Kubernetes that basically makes it sticky. So now I don't have to say Burr everywhere I go. Basically, it assumes Burr everywhere I go. Now, if you're working with an OpenShift cluster, this is the same thing as saying OpenShift project Burr, which that doesn't work on a minikube, but there's a third-party tool that makes it work for a minikube or other Kubernetes clusters. It's called Kubernetes. You can get that by saying brew install kubectx. It's part of the kubectx and Kubernetes is part of that tool if you want that one. That's part of one of the tips that I have in that presentation also. Okay, now what I want to do is actually come in here, and we have a few minutes. Let's see how fast we can go. Okay, now we're going to have to pick up the pace a little bit. So let me go to Quarkus.io. I just want to kind of show you one more time this whole process, but kind of show you something a little bit different about it. Start coding. Let's go here. Okay, I'm going to say Burr Sutter and let that get in there. There we go. And let's call this thing the Diane demo. How about that? We're hanging out with Diane today, right? And we're going to generate that application. And there it's going to download. Fantastic, it's downloading. I'm going to come back over here now. Let's create a space. Well, actually, I don't need to create a space for this. We're going to basically move it over. Diane demo, move it over. We're going to unzip it. Okay, so there we go. We're going to CD into it. We're going to do a code dot for Visual Studio Code. So this is truly from scratch, okay? From scratch. I'm going to cheat along the way, though, just to kind of show you what we're doing. But here's, let's say, my little Java application. We're using Quarkus in this case. I'm going to basically then say I want to bring up a new terminal, and I'm going to basically do this. So Maven, compile, Quarkus dev. This puts it into live dev mode. So for you, if you are a Node.js person watching right now, this is kind of where you want to pay attention, because even though I'm not using JavaScript, I'm using Java, like I was using JavaScript. All right, so watch out for this thing here. So I'm going to come over here and say, let's go to localhost 8080, and that's going to bring up this web page. So that's part of the default thing out of the box in my Diane demo. And I have hello here. Okay, so we got hello. I'm going to make this thing say bonjour, and you basically say edit, save, refresh. All right, edit, save, refresh. Edit, save, refresh. So there's bonjour. I'm going to say aloha because I'm originally from Hawaii, so aloha. Edit, save, refresh. Okay, so for our Node people here, you're like, oh my God, that's the way Node always works. And for us Java people, you just spit out your coffee on your computer because holy crap, that's a game changer. I respect that. You never see anything like this in the Java world. So I just want to show you that briefly. We don't have a lot of time to spend on it, but that's the way we work here in this new world. Let me actually add a couple other things here, though. String, let's see, string hostname, and then we're going to say system get env, get or default, yeah, that's the one we want, and yeah, we want to get the hostname out. And if we don't have a host name, we're going to say it's unknown. Come on now. Unknown, and a little semicolon there. Our Python people are like, what? What's a semicolon for? I know. Don't worry about it. Okay, so, and we're going to basically have our int count equal 1. All right, and we're going to basically now just make this a little more fun. We'll add the host name, and we'll add the count, put a space, plus. Okay, our C programmers know what's going on here. All right, so that looks okay. And let me see if let's go refresh it. All right, edit, save, refresh. Okay, unknown, that's fine. Fantastic. Oh, I know what I want to change. I want to put this on root, and I do need to fix the test because there are tests in here. I just really tore everything up, and I'm going to be a very bad developer and remove all my tests as an example. But now I basically have my application, and what the next step is you basically will come over and say Maven package if you're a Java developer, Maven package. That'll get you the application that you need to build things with, okay? To build things with, or maybe run in production, if you will. So this creates what's called an uber jar, fat jar, but in the case of Quarkus, it's actually a thin jar. So you can see here's my jar file, java-jar, Diane demo runner. Let's see, you always want to test a little bit here. So there it is, curl localhost 8080. I did make a mistake. Let's go back into Visual Studio Code. So this is what happens when you're live hacking. I left this page in here. I don't need that page. So let's go in here and delete it. Okay, right, got rid of that. Fantastic. Let's run our package again one more time. We don't need the HTML page. We just want the nice little RESTful endpoint there. Again, if you're using Node or Python, it doesn't really matter. All this works the same way. Okay, so let's run that one more time. Bring that up. And now if we curl it, all right, aloha unknown. There we go. Fantastic. All right, so that's what we wanted. So the next step as a developer, though, is you got your code, right? You're going to have to build your image. So typically you use a Docker build, okay, on your machine here. Quay.io, Burr Sutter. I call this the Diane demo. I'm going to call this, let's call it latest for now. Just keep it easy. And then there is a Docker file that we generate for you automatically with Quarkus. So it's out here in Docker land, Docker, and we're just going to pick the JVM version. I'm going to do my Docker build. Okay, so that's typically your next step is your Docker build, and the next step is your Docker push. So Docker push, and I'm going to push it up to Quay.io in this case. There we go. So it's going to push up, and so that process of build your code, Docker build, Docker push, pretty much is what everybody has to do. And then you're going to get that out here, and you can kind of look at it now. So if I come over here and go to Quay.io, and you kind of see right there, okay, Diane demo is up there. Okay. Now the next thing I need to do is have 2 YAML files. So I kind of mentioned this, because let's do this. Let's copy over. from another directory, starter, because this is exactly what I do. I basically come in here and copy existing Docker files. Library, yeah, I want that one. Copy that one over, and I'm going to copy over the service one too. Okay, so I got two YAML files now. Let's kind of go check them out. Back into my little thing here. Okay, and you can kind of see that it has this. This is the boot one that that will work at Spring Boot, but I need to go ahead and modify it. I'm going to modify it so it works for not my boot, but make it work for my app. How about that? So I'm just going to search and replace my boot for my app, and replace them. Got 9 of those things. Fantastic. And I'm going to change this right here where it says Quay.io now instead of the original image name. And then this was my Diane demo. Demo, latest. Okay, yep, looks good. That's fine. Now, notice some things here that are about the deployment that we didn't have before, right? One, I'm editing a YAML file, and this is actually the more proper way to do it because you can store this in source control now. I can basically say what replicas I want right out of the gate. I can say what resources I think I believe and request them accordingly. I can have hard limits as well. This is a hard limit. You will get killed if you go beyond the limit here. That's a C groups thing. But there's also the liveness probe and readiness probe. And let me fix this so it's actually on. They're both on root. Keep it very simple for now. Let's delay that 2 seconds. Delay this in 3 seconds. Okay? So you have to be alive and you have to be ready. Ready means I'm ready for end user load. Meaning put me in the load balancer, send me traffic from the user. That's what ready means. Live means can I respond or not respond at all. You do have to be alive to be ready. So it is kind of a 2-step process. But this one's very important for us Java people who tend to have zombie JVM processes where we don't quite clean up our resources correctly, and we have these JVMs that are running, but no one can talk to them because we basically sucked all the connections out of connection pool. Yeah, this is what this is good for. Really awesome stuff. So we got that. Let me check out our service. Oh, that looks okay. Let's see if we did all that right. So we'll come over here and say kubectl apply -f. And then someone watching right now live is probably saying, nope, we did it wrong. We'll find out. Okay, so there's my, oh, and I did get something wrong. What did I get wrong? Oh, I know what I got wrong. kubectl get events. Okay, let's go check this out. We're getting an error pulled back off. And, oh, I know why. Because by default, when you come over here to Quayland, your images, when you first push them out there, are private by default. So if you use Quay, like I do or tend to, you get to come here and click the Make It Public button. Okay, make it public. Fantastic. Let's look at my tags. Yeah, there's the latest one. And so what you're going to get a chance to see now is kind of a piece of magic of Kubernetes, which is it has this concept of a reconciliation loop. In other words, yes, things have gone badly. We broke it. I blew up my demonstration here. But if we give it a little bit of time, it'll figure out that it can fix it. It'll basically keep trying to collect that image, get it down from Quay.io, down to my local cluster here, and then get my stuff running. So look at that. And notice it says running, but it says 0 of 1. Notice it's taking a little time to go 1 of 1. That is the liveness probe and readiness probe in play. And so now we have a live running pod. So let's actually go get our service up there. This thing is still called my boot, even though I changed it. Okay, kubectl get services. Okay, minikube IP, because I can't remember what it was. Okay, it's 121. So again, while true, do curl 192.168.99.121 31548. I think I did that right. Let's put an extra echo in there, sleep it for a little bit, and done. Did I do that right? Fantastic. So there's my application, and now I can do all the rolling updates that you saw earlier and have a little fun with it, and I'll even cheat on my rolling update. I'm going to come in here and say kubectl edit deployment. Okay, and now it's called my app. All right, let's go. We're going to hack on it big time here, and I'm going to actually switch back to that my boot one that was causing me a problem. Okay, earlier, giving me outages. I said my boot v1, save, close, and let's watch what happens here. Okay, notice it's container creating, running. It's taking a little time, 0 of 1, because it's got to pass the liveness check and readiness check before my users get pushed over there, and now it says aloha from Spring Boot, and there were no errors in that cutover. All right, I have now filled the entire hour with your time. So let me kind of get back out of here and basically say, you want to get access to the slide deck, And that walks you through bit.ly 9 steps awesome. We kind of cover a lot of ground in all those 9 steps. Again, we normally run 3 or 4 hours for this workshop that I just covered in kind of 1 hour today. The presentation materials are available to you at the GitHub repo here. Okay, GitHub Burr Sutter 9 steps awesome. There's a video form of this, or a next live form when I run it again on O'Reilly. You'll see that there, but the slide deck will get you access to all the information. And Diane, I think I have covered a ton of ground, and I probably should throw it back to you at this moment.
Oh my God, that was like a tour de force, Burr. And I apologize, we have run out of time in terms of doing Q&A, but I promise you we'll bring Burr back to do more of this and the rest of his team as well. And I really appreciate you spending the time with us today. It was awesome, and we'll definitely have you back soon.